Hello, chat. Hello. Hello, chat. Hello. Hold on. All right. Let me switch. Oh, still got a rig. Oh, there we go. Okay, sick. Back to Arduino. Oh, I gotta log in. All right, hold on. I was on Ohm's law. Ohm's law. Oh, I already did that. Oh, wait. I already did this. This. I already did this. Oh, oh man. I have to do this. All right, chat. Let me get out the stuff. The Arduino kit. Hold on. Uh, okay. Oh, that's what I forgot to do from last stream. I know I was forgetting something. I have to put it in batteries for this guy. Shoot. Oh, it smells so bad too. Bro, is it the plastic itself that's melting? Low key, because of the heat, this multimeter might be melting. Yeah, it's low key melting. Like, I don't think it's supposed to smell like this. I think it's just been so hot lately that. Yeah, it's definitely cooked. I have to like cut these parts, the melted parts out. It's so cooked, guys. It's so cooked. As you can see here, I don't know if you can see it actually, but it's like melted around the seam of where. Like, I don't know where it's supposed to be cut off. No, it might be cooked, chat. I don't think I. So it does go along this seam. I don't think this is safe, chat. I don't know if this is safe or not. So there is a seam that goes here, but I don't know if I could cut straight enough for that. Yeah. Like at first I thought this was part of it, but I don't I'm starting to think that this is not part of it, bro. Let me see if I could just pry it open. Oh shoot, I've been cutting it wrong. It doesn't even go all the way down. It only goes to here. Well, I might as well cut this now that I've revealed it. But this was definitely melted by heat or something. There we go. Oh, you connect the battery. Ugh. Okay. Down, move that up. Let me put the battery in. Right, now that the battery is in, I think this is the way it goes. This way. Okay, it works now. Okay, let it be good. Lesson one. Is it the same circuit? It is the same circuit. I don't remember what I used, bro. 220 ohms is the blue one, right? Yeah. Red, red, black, black, brown. LED. Wait, was it talking about these? No, it can't be because these have plugs. Which one did I use? Four, eight to the ground. Oops. think I use reds. Reds or yellows? Let me just use the yellow. G and D to ground first. And then 13. Then I plug it in. I already did that. I already did all this.
Test and modify. In Lesson 1, you learned about Ohm's law of the relationship between voltage, current, and resistance. You'll use the circuit you just built to put Ohm's law to the test. For this activity, you'll need your flashing LED circuit, your multimeter, and your logbook. Turn to the Lesson 2 section of your notebook. 1. The power and ground jumper wires are connected to the positive and negative terminals of the breadboard. Pull these wires out just a bit so that part of the metal is exposed where the wire enters the breadboard. Don't pull them all the way out though. You want just enough metal showing that you'll be able to touch the bare wire with the multimeter test leads. Make sure that the red LED continues to flash. 2. Turn the multimeter to the 20 VDC setting. 3. Touch the red test lead from the multimeter to the exposed metal of the jumper wire connected to the positive terminal of the breadboard. Touch the black test lead to the exposed metal of the jumper wire connected to the negative terminal of the breadboard. Watch the multimeter as the built-in LED on the Arduino board flashes.
20 VDC. It's like this, right? Test. What if it's the other way? It's just negative. Okay. Yeah. That's cool. But I did somewhat of the same thing in my classes, my physics class, physics 2 class. Go to your logbook, lesson 2, and record the voltage supplied by the Arduino. LED is on. It is 6. It is 1. Whoa. Uh, Man, I don't want to do this, bro. Fine, I'll do it. Fine. What now? Honestly, the the only reason why I don't want to do this is because in my we had to do these recordings. We had to record like the voltage and all that kind of stuff. So like we had to do that so many times for the labs in my physics class, and it was so boring. It was so boring. It was like so boring.
5. Reinsert the jumper wires all the way back into the breadboard. This will keep them from pulling out as you take other measurements. 6. Set up the multimeter to measure current in milliamps. Turn the multimeter to measure a range of 200 milliamps. 7. You've measured the voltage being supplied to the circuit. Next, you will measure the current in the circuit.
Milliamps. I wish it showed me that. 200. 200 M. Uh-huh. What do I do now?
Seven. You've measured the voltage being supplied to the circuit. Next, you will measure the current in the circuit. To measure current, the multimeter must become part of the circuit. In other words, the multimeter becomes part of the conductive path that the current must pass through. The easiest way to do this is to reposition the LED. Leave the cathode of the LED in hole 4E. Move the anode from hole 2E to hole 4F. The LED should now span the center section of the breadboard.
4F. Uh-huh.
Eight. Use the multimeter to complete the circuit. Touch the red test lead to the resistor wire in hole 2D. Touch the black test lead to the anode of the LED in hole 4F. The red
Ooh.
LED should start flashing when the circuit is complete. Measure and record the current in the circuit
12.
in milliamps for when the LED is on.
divide by 1,000. So that's 12 over 1,000 amps, or 0.012 amps, right? Yeah, okay, I was correct.
Ten. Replace the LED back to its original position so that the anode is in hole 2E and the cathode is in hole 4E. 11. Next, you need to determine the resistance of the circuit. You could try to measure the circuit resistance with the multimeter. However, there's a problem. An LED requires a certain voltage to activate. This is called the LED's forward voltage. If there isn't enough voltage to push the current through the LED won't light up and the circuit remains open. This makes it difficult to measure the resistance of circuits that include LEDs. Even if the LED did light up, its resistance can change depending on factors such as the amount of current passing through it and its temperature. In Lesson 1 you learned about Ohm's law, the relationship between voltage, current, and resistance. Recall that Ohm's law states, voltage equals current resistance, or V equals IR. When the equation is rearranged, it can become resistance equals voltage/current, or R equals V/I. Instead of measuring the circuit resistance, you can calculate it. Divide the voltage of the circuit by the current in amps. Record your calculated resistance in your logbook.
One over 0.012. 83.33 repeating. I just want to create circuits, man.
You just calculated the total resistance of the circuit.
Mm-hmm.
But how much of this resistance comes from the resistor and how much from the LED? The resistor is a 220 ohm resistor. But there is a tolerance of plus or minus 5%. That means it could be anywhere from 209 to 231 ohms. To determine the actual resistance of the resistor, set the multimeter to the 2K resistance setting. 13. Anytime you measure resistance with the multimeter must become the voltage source. There should be no other voltage sources supplying current beside the multimeter. Unplug the jumper wires from the Arduino Uno R3/R4 board so that there is no power or ground going to the breadboard.
$2K. No power. No more power. Touch the red LED to the multimeter. Red. Black. There's supposed to be no power to it. Let me just take out the wires. Why are we going down? Okay, let me unplug this because this is just a weird angle to have it at. The wire's not long enough, so like, let me just put this there and this there. Zero point 21458. Zero point 214. That's where it stopped at. See if I could just get the tip to touch that. Why is it at 3 now? To 11? That's good enough. Yeah, 211. That's where it's at. That's where it keeps stopping at. Subtract the resistance of your resistor from your total resistance in the circuit. It's only 83 though. Did I mess up it? Did I mess up? I feel like I messed up. 20. Yeah, I think it's supposed to be 20. 4.53? Yeah, 4.53. Yep, I had this wrong. That's my bad. I had it on the wrong setting. 4.53 volts. And then milliamps is when you do it from. Four. Uh, 200 M. 200 milliamps. It says 11.7. How did I lose? It 11.8. 11.8 is the So this should be 4.53 over 11.8. Or no, no, no. 0.0118. 4.53 over 0.0118. Oops. Okay. 383 point 898. Three point three 383.898. Yep. That makes more sense. Then I just remove these two. Put this back. And then I connect. I put this to 2K. Then my hands are too shaky for this, bro. Two and four. Resistance of the LED. 3.898 minus 214 is equal to 3 383.214. Oh, wait, no. 3.8 is 2. 169.898. Bang. That took longer than expected, man.
16. What would happen if you powered the LED circuit with a 9-volt battery instead of the Arduino Uno R3/R4 board? Assume that the total circuit resistance stays the same. Use Ohm's law to calculate the current in the circuit when the voltage is 9 volts. Record your calculated current on your logbook.
I don't know.
17. Do you think the LED would be brighter when powered by the Arduino Uno R3/R4 board or when powered by the 9-volt battery? Use your current measurements and calculations to justify your answer. Record your response in your logbook. The battery with its 9 volts can supply more voltage to the circuit than the board and its 5 volts. However, the Arduino Uno R3/R4 board provides functionality that the battery can't provide. With the board, you can precisely control the voltage to the LED and cause it to blink or do any number of other behaviors. Software lets you program the Arduino Uno R3/R4 board to control when, where, and how much voltage to send to the circuit. The ability to automatically control components is a huge advantage in the world of electronics. Just think of all the automatic tasks that get accomplished by programming electronic devices. Your computer goes to sleep to save power after a certain time. Your phone vibrates and dings when you get a text message, the heater in the room turns on if the room gets too cold, and the security system automatically sounds an alarm and contacts the police when intruders are detected.
That is true. So if the volts equals 9, the current equals 118. So I'm trying to find the resistance. Oh, so the resistance stays the same. I have to find. So resistance stays the same. So resistance is 383.898. Current. Current equals V over R, right? Or not current. I mean, not C, I mean I. So it would be 9 over 3.898. This would be 0.0234 amps. It would be brighter. Yeah. It would the LED would be brighter because it 9 volts is bigger than the 5-volt board and its current is higher, so with higher current. Damn, this takes a long time. After this, it's series and parallel circuits. So let me just answer this. The LED would be brighter when powered by the nah by the 9 volts battery because the current is higher than higher with the battery than the board. This makes sense since the battery is 9 volts while the board is only 5 volts. Okay, I think that's it for today, chat. That took longer than expected because of the measuring. Measuring takes a while to like make sure it's on lock. And then I had to do the battery thing, but I'm hella tired. I'm hella tired. I am hella tired. So I should have done the battery thing off screen, but I look, you forgot about it. But I think, but I'll stream tomorrow. I couldn't stream this weekend because of the what's it called because I went somewhere. Damn, this thing really is melting. So, but I forgot to stream yesterday, and which was not good on my end. I low-key fell asleep. I low-key fell asleep hard once I got home. Uh, but that's that's all for today, chat. I will be I I'm hopefully streaming tomorrow. Hopefully. Oh man. I'm hopefully streaming tomorrow. Yep. All right. Hopefully I'll stream tomorrow, chat. Uh, I'll see if I'll wake up early tomorrow to stream. But if not, then it's so GG's. Because I might go get home tired tomorrow also. But I'll try my best to stream. Well, that's good night, chat. I'll see you tomorrow, hopefully. Hold on, I'm still cleaning. Alright. Good night, chat. Good night. I'll see you tomorrow. Yeah, I'll see you tomorrow. Alright.